The extinction of the dinosaurs, triggered by the Chicxulub asteroid impact 66 million years ago, marks one of the most transformative events in Earth's history. In an instant, a dominant era came to a violent end. The asteroid, roughly 10 kilometers in diameter, collided with Earth with unimaginable force, releasing energy equivalent to billions of nuclear bombs. The impact created a crater 180 kilometers wide and unleashed devastating effects: towering tsunamis, global wildfires, earthquakes, and a thick cloud of dust that blocked sunlight for years. This catastrophic event led to the mass extinction of approximately 75% of all life on Earth, including the non-avian dinosaurs that had ruled for over 165 million years. Ecosystems collapsed, food chains crumbled, and the planet was left barren and desolate. The Earth, once teeming with diverse and thriving life forms, became a quiet and seemingly lifeless world. Yet this was not the end, it was the beginning of something new. From the ashes of destruction emerged the seeds of renewal. With the extinction of the dinosaurs, ecological niches were left vacant, creating opportunities for other species to adapt and thrive. Life on Earth entered a new era, one defined by resilience and evolution. Mammals, once overshadowed by dinosaurs, began to diversify and expand, eventually paving the way for the rise of humans. Plants, too, adapted, with flowering species becoming increasingly dominant and reshaping ecosystems. The asteroid impact was both an ending and a beginning, a dramatic turning point that forever altered the trajectory of life on Earth. What followed was not just survival but a profound transformation, as life found a way to recover, adapt, and flourish in a world reshaped by catastrophe. Two, nuclear winter, aftermath of the collision. The asteroid impact that created the Chicxulub crater not only caused immediate destruction but also unleashed a prolonged global crisis known as a nuclear winter. When the asteroid struck, it ejected billions of tons of dust, ash, and debris into the atmosphere. This debris formed a dense cloud that enveloped the Earth, blocking sunlight and plunging the planet into darkness for months or even years. Without sunlight, temperatures dropped dramatically, creating a cold, inhospitable environment that drastically altered life on Earth. The lack of sunlight had devastating consequences for ecosystems. Plants, unable to photosynthesize, withered and died. This collapse of plant life set off a domino effect throughout the food chain. Herbivores, dependent on vegetation for survival, faced starvation, leading to their extinction. Carnivores, in turn, lost their primary food sources, accelerating their demise. Marine ecosystems were also deeply affected as phytoplankton, the foundation of oceanic food webs, died off, resulting in the extinction of many aquatic species. In addition to the absence of sunlight, sulfur-rich gases released from the impact site combined with atmospheric water to produce acid rain, further poisoning the environment. Bodies of water became acidic, killing off fish and other aquatic life, while terrestrial habitats were left barren and lifeless. The planet's once thriving ecosystems were reduced to desolation, with only the most adaptable species managing to endure. This period of nuclear winter represents one of the most hostile times in Earth's history. It wiped out approximately 75% of all species, including non-avian dinosaurs, and left the planet in a state of near-total ecological collapse. However, amidst the devastation, some resilient species survived, setting the stage for the gradual recovery of life and the rise of new ecosystems. 3. Massive tsunamis and widespread destruction. The asteroid impact that ended the age of dinosaurs unleashed some of the largest tsunamis Earth has ever experienced. When the Chicxulub asteroid collided with Earth near what is now the Yucatan Peninsula, it displaced an unimaginable volume of water, creating waves that reached heights of several kilometers. These massive tsunamis radiated outward across the globe, reshaping coastlines and causing widespread destruction far from the impact site. The immediate aftermath saw towering waves sweeping across the shallow inland seas and coastlines of the Cretaceous world. Evidence of these tsunamis can be found in geological deposits, where layers of sediment disrupted by powerful water currents show the devastating strength of these waves. In parts of North America, scientists have discovered sedimentary deposits that indicate water surges traveled hundreds of kilometers inland, leaving behind a chaotic mix of debris from marine and terrestrial ecosystems. The impact-driven tsunamis not only inundated coastal areas but also triggered geographic alterations that reshaped continents over time. Coastal landscapes were eroded and low-lying areas were permanently submerged. Vast amounts of debris, including vegetation, soil, and the remains of countless animals, were carried out to sea, further disrupting ecosystems. Marine environments were also severely affected as the waves stirred up the seafloor, destroying coral reefs and aquatic habitats. These tsunamis contributed to the cascading destruction caused by the asteroid impact. Coastal species, already vulnerable to habitat destruction, were among the first to perish. Survivors faced an altered world with reshaped landmasses and devastated ecosystems. The immense power of the tsunamis highlights the scale of the disaster, illustrating how the asteroid impact not only triggered mass extinction but also permanently transformed the geography and ecology of the planet. 4. Earth's recovery, the rise of new life. In the aftermath of the asteroid impact and the devastating nuclear winter, Earth entered a slow but steady process of recovery. Thousands of years after the dust and ash settled, sunlight gradually returned, temperature stabilized, and ecosystems began to rebuild. While the mass extinction had wiped out approximately 75% of all species, it also created opportunities for the survivors to thrive and evolve. Among these survivors were small mammals, birds, the descendants of avian dinosaurs, reptiles, and certain hardy plants, all of which played crucial roles in the planet's rebirth. Mammals, which had remained small and relatively insignificant during the age of dinosaurs, emerged as key players in the New World. Their small size, ability to burrow, and varied diets allowed them to endure the harsh post-impact conditions. With the dominant dinosaurs gone, mammals began to diversify rapidly, evolving into new forms and occupying ecological niches once controlled by the dinosaurs. Early placental mammals, marsupials, and monotremes started to thrive, setting the stage for the eventual rise of larger mammals, including primates. Birds also played a significant role in Earth's recovery. As descendants of theropod dinosaurs, they carried forward a lineage of adaptability, evolving into diverse species capable of exploiting different environments. These early birds helped repopulate ecosystems, spreading seeds and contributing to the growth of new vegetation. The planet itself experienced a botanical rebirth. Hardy plants like ferns, which could grow in poor soils, were among the first to recolonize barren landscapes. Over time, flowering plants, angiosperms, became dominant, reshaping ecosystems and providing new food sources for herbivores. This period of recovery marked the beginning of a new era. From the ashes of extinction emerged a dynamic and evolving biosphere, paving the way for the development of complex ecosystems and the eventual emergence of modern species, including humans. 5. Emergence of new species. As Earth slowly recovered from the devastation of the asteroid impact, the planet entered a period of renewal marked by the emergence of new species and ecosystems. With dinosaurs no longer dominating the land, mammals and birds began to rise as the planet's new rulers. These adaptable survivors not only thrived in the altered world but also evolved rapidly to fill the ecological niches left vacant by the mass extinction. Mammals, in particular, underwent a remarkable transformation. Once small, nocturnal creatures that lived in the shadows of dinosaurs, they began to diversify in size, behavior, and habitat. Placental mammals, such as early rodents and insectivores, became particularly successful, spreading across continents and exploiting a variety of food sources. Marsupials also flourished, evolving unique traits to adapt to their environments. Over millions of years, these mammals gave rise to larger and more complex species, including early primates, which would eventually lead to the evolution of humans. Birds, the descendants of theropod dinosaurs, also adapted to the changing planet. Their ability to fly allowed them to spread quickly and colonize diverse environments. Over time, they evolved into the wide array of species we recognize today, from songbirds to waterfowl, contributing significantly to the recovery and rebalancing of ecosystems. The planet's vegetation underwent a dramatic shift as well. Flowering plants, angiosperms, which had begun to appear during the late Cretaceous, flourished in the post-extinction world. These plants formed the foundation of new ecosystems, providing food and shelter for animals and reshaping the Earth's landscapes. Forests and grasslands expanded, creating habitats that supported the rising dominance of mammals and birds. While Earth's recovery was slow, it marked the start of a new era. Though life rebounded, the planet never returned to its former state. Instead, it evolved into a dynamic and ever-changing biosphere, laying the groundwork for the incredible biodiversity we see today. 6. Post-extinction Earth's environment. The extinction of the dinosaurs drastically reshaped Earth's environment, creating a planet unlike the one they had dominated for millions of years. In the aftermath of the asteroid impact, the Earth's climate underwent significant shifts, setting the stage for the rise of mammals and birds. These changes, coupled with the absence of dinosaurs, allowed new life forms to adapt and thrive, filling the ecological niches left vacant by the mass extinction. In the immediate aftermath, Earth's environment was cold and barren, with a nuclear winter halting photosynthesis and slowing recovery. However, as sunlight returned and temperatures began to stabilize, the planet underwent a period of climatic fluctuation. The late Cretaceous world had been warm and humid, but the post-extinction climate gradually cooled, favoring species capable of surviving in more temperate conditions. Mammals and birds, both small and adaptable, flourished in this new climate, evolving rapidly to exploit available resources. With dinosaurs gone, mammals diversified into a wide range of forms. Small insectivores and omnivores expanded their diets, while early herbivorous mammals adapted to feed on the flowering plants, angiosperms, that now dominated the vegetation. Over millions of years, these mammals grew larger and more specialized, filling roles previously held by dinosaurs, such as large herbivores and apex predators. Similarly, birds evolved to occupy various ecological niches, becoming forest dwellers, scavengers, and even aquatic hunters. Marine environments also saw the rise of new species. Mammals like early cetaceans, ancestors of whales, began adapting to life in the water, while surviving reptiles and fish diversified to replace species lost during the extinction. The post-extinction environment was a time of immense change and adaptation. Though Earth's ecosystems never returned to their pre-impact state, they transformed into dynamic systems driven by the resilience of life. This period marked the dawn of the age of mammals and birds, setting the stage for the extraordinary biodiversity we see today. 7. Lessons from dinosaur extinction. The extinction of the dinosaurs serves as a powerful reminder of the unpredictability and fragility of life on Earth. Environmental changes, whether triggered by sudden catastrophic events like asteroid impacts or gradual processes like climate shifts, have the potential to disrupt ecosystems and drive mass extinctions. The lessons from this ancient event resonate deeply with the challenges we face today, offering a cautionary tale about the delicate balance of our planet's environment. The asteroid impact that ended the age of dinosaurs was a natural disaster beyond human control, but it underscores how external forces can reshape life on Earth in an instant. In contrast, many of today's environmental challenges, climate change, habitat destruction, and pollution, are driven by human activities. These issues mirror some of the conditions that contributed to the dinosaurs' extinction: rapid climate fluctuations, ecosystem collapses, and loss of biodiversity. Just as the dinosaurs were unable to adapt to their drastically altered world, many modern species face similar threats in the face of rapid environmental changes. This historical perspective highlights the importance of taking proactive steps to protect the planet. Investing in conservation efforts, reducing greenhouse gas emissions, and preserving biodiversity are critical to preventing the kind of widespread destruction seen during the Cretaceous-Paleogene extinction event. Understanding the interconnectedness of ecosystems and the long-term consequences of environmental changes is key to ensuring the survival of current and future life on Earth. The extinction of the dinosaurs also emphasizes the value of scientific research. By studying ancient events like the Chicxulub impact, scientists gain insights into potential risks, such as asteroid collisions, and develop strategies to mitigate them. These lessons remind us that while life on Earth is resilient, it is not invincible, and that protecting our planet is both a responsibility and a necessity for the survival of all species, including our own. 8. Conclusion. The extinction of the dinosaurs was a pivotal moment in Earth's history, marking the end of one era and the beginning of another. The recovery that followed was long and arduous, taking millions of years for ecosystems to rebuild and for life to flourish once again. While the asteroid impact and its aftermath brought unimaginable destruction, Earth demonstrated its resilience through the rise of new life forms, including mammals and birds, which eventually gave rise to modern biodiversity and humanity itself. Though life continued, the planet was forever changed. The once dominant dinosaurs were replaced by species better suited to the new environmental conditions. Flowering plants reshaped ecosystems, mammals diversified into roles once held by dinosaurs, and birds carried forward a lineage of adaptability and survival. This transformation highlights the incredible resilience of life, capable of adapting to even the most catastrophic changes. However, the extinction event also serves as a stark warning. The delicate balance of Earth's ecosystems makes life vulnerable to sudden disruptions. Today, the threats posed by climate change, habitat destruction, and biodiversity loss echo some of the challenges faced during the extinction of the dinosaurs. These modern challenges, though driven by human activity, remind us that environmental changes, whether gradual or sudden, can have irreversible consequences. The lessons from this ancient event are clear. The survival of life depends on protecting our planet. Preserving ecosystems, mitigating climate change, and taking measures to prevent future disasters, such as asteroid collisions, are crucial steps in safeguarding Earth's future. The story of the dinosaurs and Earth's recovery is a testament to both the fragility and resilience of life. A reminder that while life can adapt, it is up to us to ensure it has the opportunity to do so.